Hello everyone. This is another video on this is a video lecture series on gate PYQs, and here we'll be solving gate questions of 2022. Right? This is gate 2022 physics, and we'll be solving all the questions. We'll be trying to go into the concepts and solve them. All right. Okay. So the first question in physics part, I'm skipping the general aptitude part. Okay. I'm gonna solve the physics questions. So for the op-amp circuit shown below, choose the correct option output waveform corresponding to the input. V in is equal to what? 1.5 sine 20 pi t. Alright. The saturation voltage for this circuit is V saturation is equal to minus 10 volt. Alright. So this is the question. Okay. So you are asked what is the saturation voltage for this circuit. There are some graphs given. Alright. So how to get it? See, this is called a what? It's a positive feedback. This is a positive feedback, and what is it's called a what? It's called a Schmitt trigger circuit. Okay, Schmitt trigger. So what happens in Schmitt trigger circuit is the output will always be saturated. Okay, the output will always be saturated, saturated. That is, it will be that is limited. That is limited between. It is limited between what? Limited between what? The plus V saturation to minus V saturation. What is plus V saturation here? Can you tell me? See, V saturation is given as plus or minus 10 volt. So plus V saturation is plus 10 volt to minus 10 volt. This is the limit of the output, right? So the output will eventually be between plus 10 to minus 10. So here see, this is plus 10 and this is minus 10. If option B, it is only at plus 10. So this is not possible. Next, option C, it's going from 0. No, no, it's not possible. And this one is only 0. So this is not possible. So the answer is what? Answer is option A, where the voltage is what? Between plus V saturation to this is minus V saturation. Okay, because this is a Schmitt trigger circuit. It's an important concept in op-amp. Okay, and it came for 1 mark. Okay. So yeah, so this is your number 11. Okay, next question. Question number 12. Match the order of beta decays. Match the order of beta decays given in the left column to appropriate clause in the right column. Here X I pi and Y I pi are nuclei with intrinsic spin I and parity pi. Okay, intrinsic spin I and parity pi. So we have to give which order beta decay it is. All right. So see, mm, see, in beta decay, what happens is if there is no parity change, then it is allowed beta decay. Okay, allowed beta decay. And if like what like the parity is changing. Okay, del pi means parity is changing. Parity changing. Okay, and del I is equal to 2, then it's called first forbidden. Okay, let me write it at a very better place. Okay, see here. Write it here, right? Good thing about it, through this we can, like, what happened? What's happening? What's going on? Something is wrong with the pen. Okay, right. Yeah, now it's all right. Now it's all right. Okay. So, so what I was saying is, okay. Let's discuss then beta decay. Okay. Okay. Beta decay. So what happens there is, write down. For example, del I is 0 and del pi is that no. That means no change in parity. Then it's what? It's allowed beta decay. Allowed beta decay, isn't it? For example, del I is 2 and del pi, that means there is change. Yes, there is. Yes, there is change in parity. If there is change in parity, that is what? And del I is, that is first forbidden. Okay, first forbidden beta decay. Now del I is equal to 4, but this one is not changing. No change in parity. So that is called second forbidden. Del I is 3, sorry. Second forbidden beta decay. Okay, and del I is what? 4, and there is change in parity, then it is called third forbidden beta decay. Third forbidden beta decay. Alright, so let's see in this question. Let's see in this question what are the how can we do this? Okay, see. Okay, del I 0. Let's go with the first option. Half plus 2, half plus, right? Half plus 2, half plus, plus to plus. There is no change in parity here. Okay, so there is no change in parity. So del pi is equal to 0. Now can you tell me, this is I, right? I plus I1. Okay. So what is del I here? Del I is half minus half. That is 0. So del I is 0. Del pi is, that means no change in parity. That means this one is what? Allowed beta decay. Okay. I is allowed beta decay. So 1 goes to this. Clear? Okay. Clear? Now, this one, let's go to this one. Half minus 2, 5 by 2 plus half minus 2, 5 by 2 plus. Here, del pi is changing. Yes, there is a change in parity. Now, del I is how much? 5 by 2 minus 1 by 2, that is 4 by 2, that is 2. So, del I is 2, parity is changing. That means this is what? First forbidden, isn't it? This is your first forbidden. So, it goes like this. Right, now this one, 3 plus 2, 0 plus, no change in parity, del pi is 0, no change, and del I is how much? Del I is 0 minus 3, that is 3, that is 3. So del I 3, no change. That means what? This is second forbidden. It's properly arranged, and this one is left, that is third forbidden. They see, parity is changing and delay is 4. So third quadrant. So here 1 IV, 2 I, 3 double I, and 4 triple I. Alright. So let's see which option is saying. Yeah, this one. Option B. Okay. That is 1 mark. Okay. Yeah. See how conceptual question it is. Okay. Yeah. Next. Question number 13. What is the dimension number for? Let me check. Okay. So, what is the maximum number of free independent real parameters specifying an n-dimensional orthogonal matrix? Or maximum number of n-dimensional maximum number of free independent real parameters specifying an n-dimensional orthogonal matrix. Orthogonal matrix. All right. Let's see this question. So, uh, for example, there is a matrix A. Okay, A B C D. So, what is the this is A B C D. Okay, what is the what will I say? What is the condition to for A to be orthogonal? A transpose into A is I orthogonal condition. Orthogonal condition. Right. So A transpose would be how much? A B C D. Okay. A B C D. So A is A B C D. So let's multiply them and see. So if I multiply them, A transpose into A C B D into A B C D, that is how much it will be coming? A square plus C square, A B plus C D, um, A B plus C D, B square plus D square is equal to I, right? I means 1001, right? So you can see A square plus C square is equal to 1, B square plus D square is equal to 1. Alright, correct? Okay. So see, you can we can see here that and also so there are two constraints on diagonal elements. Okay, these are the two constraints on diagonal elements. Okay, that means this will make two parameters components dependent. Okay, right. Now also we can write that um, AB plus CD is equal to how much? 0, right? So one constraint, that is also one constraint, okay, on the value of diagonal elements. So this will make one more component in dependent. Okay, so the total number of dependent components will be how much? Total dependent components will be how much? 4 minus 3, that is 1. Okay, we see that 4 minus 3, 1. Okay, 4 minus 3 is equal to 1, isn't it? 4 minus 3 is equal to 1. All right. So for this is a 2 by 2 matrix we have taken. So how can we get 1 from a 2 by 2 matrix? If I write like this, n over to n minus 1 by 2. See, 2 over into 2 minus 1. 2 by 2 is 1. So this is the formula that I can use, isn't it? See, 2 over into 2 minus 1 by 2. This is giving me 1. 2 over into 2 plus 1 by 2 is not giving me 1. Or this one is also not giving me. Yeah, this is by chance giving me 1. But this one is also not giving me. So this is the perfect one. Okay. So n over to n minus 1 number of what? Independent components. Is it right? Is it clear? Okay, you have to take an example. Okay, you have to take an example and see it. right? Yeah, this is number 13 for 1 mark, right? An excited state of calcium atom is magnesium 3p5 4h2 3d1. The spectroscopy terms corresponding to the total orbital angular momentum are, right? So how do we calculate it? Tell me. So it will correspond to the total. An excited state of calcium atom is this one. Okay, an excited state. So, so what can we do? How to get the total orbital angular momentum? Okay, total angular momentum. See, this one is full, so we cannot do anything with it. All right, and this one is there is one electron here. There are five electrons in P. Okay, so we have to ignore this S part for getting it. Okay, we have to ignore this one also because there is only one electron there. So we have to consider only the what? Only the p electron. Okay, we have to consider only the p electron. So and the d electron. Sorry. P electron and d electron because there is 5 on 3d5, 3d1. So these are incomplete. So sorry 3p5, 3p5 and 3d1. So one p electron, one d electron will consider. Okay, so for P it is what? L is equal to 1. For D, L is equal to 2 because S, P, D, F 0. L value 0, 1, 2, 3. So P1, D2. Okay, so total orbital angular momentum will be total orbital angular momentum will be how much? L is equal to what? L1 plus L2 dot L1 minus L2, isn't it? So 1 plus 2 dot dot 1 minus 2. That means 3 to 1, isn't it? 3 to 1. So 3 to 1 means what? These are the L values, capital L values. So for 3, L is equal to 3, your thing is F, right? For 2, it is D, for 1, it is P. So P, D, F, these three. P, D, F. Option B. You get it? PDF, that means option B. Alright? Yeah, this should be your answer. Alright? Yeah. Get it? We have to take the electrons in these two. 4h2 is complete, so we cannot take it. So, like, and magnesium we won't take. So 3p5 and 3d1, and we took the L values and we just added them like this one L1 plus L2 to L1 minus L2. So 14 is over. That is 1 mark. Okay, 1 mark question. Okay, next question. On the surface of a spherical cell enclosing a charge-free region, spherical cell, charge-free region. Illustrative potential values are as follows: 1/4 of the area has potential phi naught, 1/4 of the area. Another per quarter has potential 2 phi naught, and the rest has potential 4 phi naught. Okay, and potential at the center of the cell is. You can use the property of a solution or Laplace equation. Yeah. So center at the potential at the center of the cell we are asked. All right. So how to do this one? How to do this one? Let's do it. I have to do it differently here. It's a longer question. Okay. Okay. So, how to do this question? See, we know potential is V r theta is equal to summation A alpha r alpha P alpha Okay, cos theta. This is the what? Legendary like this one. Okay. So a naught r to the power 0 p naught cos theta. Okay. Plus a1 r1 p1 cos theta. It will go on and on, right? So v r theta is what? V r theta is a naught because r naught is this is one. This is also one. A1 r p1 cos theta plus it will go on and on. Okay, plus it will go on and on. Okay, so potential at the center is only decided by a naught. Okay, so we have to find a naught. Like v r theta here, it will be like it will be decided through a naught, right? So if we can find a naught, we can do it. Okay, so it can be shown that what area of the sphere from 0 to 0, of the sphere from 0 to pi by 3, okay, pi by 3 to pi by 2, pi by 2 to pi is what is this area? This is pi r square. Okay, this is pi r square, this is 2 pi r square. All right, isn't it? Yeah. So let's apply boundary condition. What are the boundary conditions? Boundary condition. Boundary condition would be v r theta is equal to, so phi naught, 2 phi naught, 4 phi naught, isn't it? So this is for what? This is theta 0 to pi by 3. This is sorry, pi by 3 to pi by 2, and this is theta pi by 2 to pi. All right. So v r theta, as we know, again I will apply v r theta. V r theta, okay, is equal to summation a alpha r alpha p alpha cos theta. Okay, so a alpha is how much? 2 alpha plus 1 to r to the power alpha 0 to pi. If you are unable to understand this question, then you can skip this because it's a very lengthy question. Should not be wasting time on lengthy questions in the exam hall, and also this will mess up your mind. So it's better to leave this. I'm just doing it because I had to. I cannot just leave the question because it's lengthy. So a naught will be what? This is 1 by 2, 0 to pi. Okay. Um, v r theta, p naught cos theta, right? P naught cos theta is 1, and sin theta is sin theta d theta. Okay. So a naught will be what? A naught will be, see, 1 by 2. This will be, have to take the every limit. Okay. Phi naught potential, phi naught limit, then sin theta d theta. Okay, this is from 0 to pi by 3. Then pi by 3 to pi by 2. What is the potential in pi by 3 to pi by 2? 2 phi naught, right? So I will take 2 phi naught sin theta d theta. Okay, because I'm just putting the values of b theta here, here, now here. Okay, now comes the easy part. Up to this point, it's a bit conceptual. Pi by 2 to pi, phi naught sin theta d theta. Sorry, sin theta d theta. All right. So from here, I can do what? This is phi naught. Okay, phi naught and minus cos theta 0 to pi by 3. All right, plus 2 phi naught minus cos theta pi by 3 to pi by 2 plus phi naught minus cos theta, okay, pi by 2 to pi. Okay, so this becomes a naught becomes 1 by, sorry, 1 by 2 minus 1 by 2. Okay, phi naught, see, minus cos pi by 3. Okay, take all the minus outside this, please. Yeah, So cos pi by 3 is 1 by 2 minus 1 plus 2 phi naught. Cos pi by 2 is 0 minus 1 by 2 plus phi naught. Cos pi is minus 1 minus 0. Alright. So this becomes minus 1 by 2 phi naught minus 1 by 2 plus 2 phi naught minus 1 by 2. This is minus phi naught, isn't it? So minus, if I multiply phi naught by 4 plus 2 phi naught by 4 plus phi naught by 2, that will be 4. If I take the LCM, phi naught plus 2 phi naught plus 2 phi naught, that is 5 phi naught by 4, isn't it? 5 phi naught by 4, is it correct? Or I made a mistake? You're doing mistake. I think I made a mistake somewhere. Okay, okay, this is 4 phi naught. Because see, this is 4 phi naught, right? Here, the limit. So this should be 4, 4. I made a mistake. So this is your 4, 4. Okay. See, simple mistakes can cost you a lot of things. So this is your 8 then, okay. So this becomes 11 phi naught by 4, okay. This should be your answer. The potential is what? Potential at center is your actually A naught. So 11 phi naught by 4. Okay, this is your answer. Alright. Yeah. Okay. So the question number 15, I think. Hmm. So we'll move to the next question. Question number 15 over. 1 mark. Okay. Next question. A point charge Q is performing simple harmonic oscillation. Okay. Oscillation of amplitude A at angular frequency omega. Using Larmor's formula, the power radiated by the charge is proportional to. Power radiated by the charge is proportional to what? Okay. So, um, see, this is what, isn't it? Is equal to Q A omega. Okay. Sin omega t, no? Sin omega t, or sorry, cos omega t. Okay. So P dot is what? P dot is minus Q A omega, hmm, sin omega t. There's no omega here. Q A cos omega t, because x t is A cos omega t minus Q A omega sin omega t. P double dot is how much? Minus Q A omega square cos omega t. Alright. So cos omega t. So your power radiated by charge is what? Proportional to actually P double dot square. Okay, which is proportional to Q square A square omega 4. Okay, Q square A square omega 4. Where is it? Yeah, option D. Again, PT is equal to QXT. XT is what? A cos omega t. And then I took P dot is equal to minus Q A omega sin omega t. P double dot is this much. So P is equal, P like power radiated is equal to P double dot square. Okay, this much. Okay. So this is a 16 number, 1 mark. Okay. Next question. Which of the following relationship between the internal energy U and emergent energy F is true? Okay. So internal energy U and hemorrhage energy free. So we can relate them as F is equal to U minus Ts, isn't it? F is equal to U minus Ts. If I take the differential, dF is equal to what? Du minus TdS minus STT. Du can be written as TdS minus PdV, isn't it? minus TDS minus STT. So TDS cancel, so it is minus PDV minus STT. Okay, minus PDA minus SDT. So this is your DF. So from here S is equal to how much? Minus del F by del T when V is constant. Okay. So I will put it again. F is equal to U plus TS. In place of S, put F is equal to U plus T. Sorry, minus. This will become minus del F by del T whole S. Sorry, whole V. Okay. Right. Uh, or did I do a mistake? No, that's right. So U will become F plus T del F by del T at V. Okay. Yeah. So what can I do from here is I will write it here. Okay. Because it's like space is not there. Let me do it again. F is equal to U minus TS. DF is equal to DU minus TDS minus STT. DF is equal to DU is what? TDS minus PDV minus TDS minus STT. How DU is like that? DQ is equal to DU plus DW, where DU plus PDV is equal to TDS. From there, DU is TDS minus PDV. Okay, so TDS minus PDV minus, so these two got cancelled. So minus PDV minus STT. This is DF. S is equal to minus del F by del T at constant volume. Right, so I can put this one here. So F is equal to U minus T minus del F by del T V. Okay, so U plus T del F by del T F. Okay, so U is equal to F minus T del F by del T at constant volume. Alright, now what? Now see, can I do this? Del by del T of F by T at constant volume is equal to what? By T at constant volume is equal to what? 1 by T del F by del T at constant volume minus F by T square. Okay, isn't it? See, 1 by T del F by del T at constant volume minus like F by T square. It's just the derivative here. I didn't do anything, just the derivative. First, I took the derivative of 1 by like F, and then the derivative of the 1 by T. Okay, so I can write it as minus 1 by T square common. So it will be what? F minus T, right? I can write this one. So if you check, this is what? This is it. So I can add this one as what? Minus U by T square. Okay, minus U by T square. Isn't it? So minus U by T square is how much? The left side, del by del T of F by T at constant volume. Okay, so this is what? U is equal to minus T square del by del T of F by T at constant volume. This is the equation. Let's check whether it is there or not in the options. Okay, just have to do some this kind of thing. Easily you can do it. See, it's one option A. Okay, very easy, not hard. You can easily do these questions. 1 mark, thermodynamics. Right. Next question. Question number 18. If nucleons in a nucleus are considered to be confined in a three-dimensional cubical box, then the first four magic numbers are three-dimensional, sorry, cubical box. Nucleons in a nucleus are confined. Okay, so what is the magic number? So energy is what? Energy for energy. Okay, let me do it differently. Okay, energy. Wait. Yeah, energy in a cubical box. Energy is how much? E is equal to nx square plus ny square plus nz square. Okay, pi square h square by 2 ml square, isn't it? So let's do one thing. Here we'll write like this: nx, ny, nz. Right? Hmm. So what are the magic numbers? You see, 1, 1, 1, 1, 1, 2, 2, 1, 1, 1, 2, 1. Right? 1, 2, 2. Hmm. Then 2, 1, 2, 2, 2, 1, 1, 1, 3, 1, 3, 1, 3, 1, 1. Okay? First four magic numbers. Okay? So 2 will be everywhere. 2 nucleons here, 2 nucleons. 2, 2, 2. Okay? 2, 2, 2, 2, 2, 2. Okay? So the magic numbers will be what? So the magic number should be, this is 2. Just a second. Hello. Hmm. Hmm. So the magic number should be here. This should be, sorry, this should be 8. Alright. Then what? Then along with this, there should be 14. Hmm. And at the end, it should be 20. Okay. So the magic number should be how much? C, option C, 2, 8, 14, 20. Is it clear? Even if it's not clear, you just go and check the magic numbers. Alright. 2, 8, 14, 20. Okay, options, it's number 1 mark. So you try in the next question, you try. I'm coming in 2 minutes. Alright. 2 minutes you have. Try. Okay, sorry for the delay. Okay, so did you try this question? Consider the ordinary differential equation y double dash plus 2xy dash plus 4y is equal to 0, right? So let's try this question. Y double dash y double dash minus 2xy dash plus 4y is equal to 0. Okay, so what is the question? Okay, its solution is given bx plus cx square. So which is correct? Okay, what do I do? Let's directly put it. Let's see what happens. dy square y by dx square minus 2x dy by dx plus 4y is equal to 0. So this should be what? This should be 2c minus 2x b plus 2cx, okay, plus 4a plus 4bx plus 4cx square is equal to 0. So 2c minus 2bx minus 4cx square plus 4a plus 4bx plus 4cx square is equal to 0. These two got cancelled. So 2c plus 4a plus 2bx is equal to 0. Okay, so c plus 2a plus bx is equal to 0. Okay, this is what I'm getting. Hmm. Otherwise, let's try another way. Y is given from this way. Let's go. Y is equal to a plus bx plus cx square. So y dash is equal to b plus 2cx. Y double dash is equal to 2c. Right? Yeah. So now let's put this value and this value in this equation. Okay, we'll do this way now. So let's put the equation value of so the equation was y double dash minus 2xy dash plus 4y is equal to 0. So y double dash we got 2c, y dash is equal to b plus 2cx. So let's put it here. Sorry, 2c minus 2x b plus 2cx is 4y. Y is how much? Y is y. Y is given. Y is a plus 2b sorry, plus bx plus cx square is equal to 0. 2c minus 2bx minus 4cx. I think it will be coming same. 4bx plus 4cx. So yeah, it's the same thing. Okay, I get it. I get it. How to do it. So see, this one. See, there is no coefficient of x here on this side. So 2b is equal to 0. If we compare the coefficients, and if now 2c plus 4a will be 0. So c will be minus 2a and b will be 0. I think that should be the answer. Yeah, yeah, it was easy. We were almost there, but I just could not like get it at the last moment. Yeah, it was there. It was there. Okay, so let's check the options. Let's check the options. Option will be what? C is equal to minus 2a. Yeah. Not equal to B. I think option C, option B. Yeah. C is equal to minus 2a, not equal to 0. And B is equal to 0. One mark. Okay, this was the question number 19. Question number 20. For an open based negative feedback non inverting amplifier, which of the following statements are true? The following statements are true. Okay. Open based negative feedback. Okay. Closed loop gain is less than open loop gain. That is true. Okay. Closed loop bandwidth is less than open loop band. That's not correct. Closed loop input impedance is greater than open loop input impedance. That's correct. And closed loop into output impedance is less than. That's correct. Okay. If you see, these two are same options, isn't it? It's just it's like change of place. C and D are correct. A is correct. So yeah, A, C, D. C and D options are same thing. It's just greater is smaller. Same thing. All right. Yeah. From the pair of 21. That's one mark. From the pair of operators given below, identify the ones which commute. Commute means AB. Commute means what? AB commutator bracket is equal to 0. Here L and J corresponding to the orbital angular momentum and total angular momentum respectively. Okay, so let's check which are commuting. Okay, let's check. Let's start from the last part. LZ, JZ. Okay, so we have to take psi, isn't it? So LZ, JZ, psi minus JZ, LZ, psi. So okay, wait. Anyway, let me see. I'll tell you a concept. See, J square, L square, S square, and JZ all commute with L dot S. Okay, all commute with L dot S, but they don't. These they commute with L dot S commute, but they don't commute with what? They don't commute with LZ. Okay, not commute. Yeah, they commute with L dot S, but they don't commute with LZ. So L square J square. Yeah, commute J square JJ. Yeah, they commute. J square LZ. No, they don't commute. They don't commute. Just commute. Just commute. LZ JZ. LZ JZ. I think. Yeah, they commute. Okay, these two commute. JZ and Z. Okay, so option A, B, D will be correct. Option C will be wrong. Right? Yeah, they won't commute. Yeah, these are MSQ questions. Okay, 2 marks. 21, 22. From a normal Zeeman lines observed parallel and perpendicular to the magnetic field applied to an atom, which of the following statements are true? This is a like memory based question. Like see for parallel Zeeman lines, normal Zeeman lines. Okay, normal Zeeman lines. I write the concepts. See, sigma lines are perpendicular to the field are what? Plane polarized. Okay, then only sigma lines are observed parallel to the field. Parallel, which is on the option D, and this one is also pi lens perpendicular also plane polarized. So sigma lens perpendicular are plane polarized, pi line perpendicular are plane polarized, and sigma lines are parallel to the field. Okay, pi lines are observed perpendicular to the field. Okay, so these points you need to remember. It's 2 mark MSQ in a gate 2022. Next, Pauli spin matrices satisfy sigma s sigma beta minus sigma. Okay, this one, this one, this one. Okay, let's see which one will be correct. See, we know this one. We know this is memorization. Like is equal to how much? 2y sigma z, isn't it? So you can see this is kind of same thing where it's saying alpha beta beta alpha is giving me alpha gamma with 2. Okay, and what, and just a second. Hello, decay 5 minutes. Okay, so next is Paulis. Okay, next also like yeah 2y. If they are like minus, this will be 2y. But if like they are giving me plus, there is a plus between them. That will be 2 sigma. Okay, that is okay. Okay, so option B and D are correct. All right, 2 marks. Next is for the refractive index n is equal to this of material. Which of the following statements are correct? Okay, so NR can be determined for NIM and vice versa. That's correct. NIM could be 0. That's not correct. NIM cannot be 0. N is an analytic function in the upper half of the complex plane. That's correct. N is independent of omega for some materials. That's not correct. So A and C are correct answers. Okay, 2 marks. 25. Complex function is continuous, complex differentiable, complex different analytic. Okay, let's see this question. Okay, so f of z is equal to this much. So x plus iy plus x plus iy minus a whole square. Okay, this is your fz, isn't it? So continuous at a. So I can write it as x plus x minus a whole square plus y square plus iy, isn't it? Can I write like this? Okay. So if I continue continuity at a continuity at a parallel to x axis, right? So what will I do? Limit z tends to a, f of z is equal to limit x tends to a, f of z, y is equal to a. All right. So if you put it, it's equal to limit x tends to a, x plus x minus a whole square plus a square plus ia. All right. So this will become a plus a square plus ia. Parallel to y axis will be limit z tends to a, f of z is equal to limit y tends to a, okay, f of z at y is equal to a. So that will be x plus x minus a whole square plus y square plus iy at a, isn't it? At a. So that will become a plus a square plus ia. So you can see those are matching. That means they are continuous. Okay, they are what? Continuous. That way you can also prove that they are complex and differentiable at a and 0. Okay, so option A and C will be the correct options. Right? Yeah, this was the question number 25. So up to 11 to 25 we discuss in this class. Okay, we'll be solving from 26 to 14 the next one. 15 questions we'll do. Okay, so that it doesn't feel heavy. Okay, all right. Yeah, that should be it for this class. We'll see you in the next class. Thank you.